This is question 14 and it's a question about angles in a circle. It says find the size of angle ABD. So first of all, I'm going to just indicate the angle that we're looking for so we can see where we're going with this question. And that's here, because if you use the 3-letter angle system, then ABD, the angle is at the center letter there. So this is the angle that we're interested in. So I might just call that X for the moment, just so we know what we're looking for. So we've got to also give a reason for each stage of our working that's going to enable us to find what X is. Now in these, one of the strategies, if you're not sure where to go with it, is you could just try and find any angle, and then hopefully eventually once you find enough angles you can find the one that you're looking for. The first one I'm going to use is I'm going to find this one here. So this is angle DBF. So notice that the letter in the middle is where the angle is. I might even put a little hat on it. That's one of the symbols that they can use to show that it's an angle we're looking for. And we can see that DBF is actually 180 minus 100. And that's because angles in a cyclic quadrilateral, which is what we've got here, we've got a 4-sided shape in a circle where each of the corners touches or lies on the circumference of the circle. So I need to put the reason in there. Opposite angles in a cyclic quadrilateral add up to 180. So generally speaking, that's how you can put your reasons in for these things, because you can just do the calculation but put the reason in a bracket afterwards. So we've got that DBF, if we do this calculation, is equal to 80 degrees. I'm just going to label that there. So now we've got DBF, we know that's 80 degrees. What we can then do is find BFD, that's the next easy one to find, and we can find that using the angles in a triangle adding up to 180. So we can say that BFD, so again the middle letter gives where the angle is, BFD is going to equal, and I like to write it like this, 180 minus the other two sides added in a bracket there, so plus 40 plus 80. And the reason there, so I'm just going to put that again in brackets, is that angles in a triangle add up to 180. So if we continue with that calculation, we can see that it's 180 minus 120, which is 60. So I can put that on there. And then finally, we're actually nearly there now, because there is a rule called the opposite segment theorem, which means that if we have an angle between the tangent and the base of this triangle here, so I'll just indicate that. So here's the tangent and here's the base of our triangle. The angle there is considered to be in one segment of the circle, so that's the segment I've just shaded in, and then the other angle here is considered to be in the other segment of the circle. So here we go, I've messed up the diagram here, but we can see what we're doing. So this one here is in the opposite segment and they're equal. So we can say that ABD, which is actually X as well as I've indicated there, so ABD is equal to 60 degrees, and it's because of the opposite segment theorem. So I hope that's been helpful to you, and if it has, please consider subscribing to our channel and also giving the video a thumbs up. Thanks for watching.